Hi everyone, today we're talking about chapter 8.3 and this has to do with geometric sequence and series. Previously we've talked about arithmetic sequences, and these are sequences where you take one term and you add a common difference to get the next term. For example, you go from 3 to get to 6, you add a common difference of 3 each time to get the next term. All right, that video is from Friday. Today we're talking about a geometric sequence, like the pattern of 1, 4, 16, 64, 256. You'll see these numbers are growing really fast. And so when you look to identify a geometric sequence, you're going to look at the common ratio. So the ratio of any term to the previous term is constant, and this constant ratio is called a common ratio, and we're going to use the variable r. So if you take a look at 1 and 4, okay, the common ratio, you take the second term, 4, divided by 1, and if that is common across all the pattern, that's a common ratio, and therefore you'll have a geometric sequence. So you check 16 divided by 4. Is that also 4? Yeah. And then check 64 divided by 16. Is that equal to 4? Yep. And 256 divided by 64. That is also equal to 4. So there is your common ratio of 4 to form that geometric sequence. So we're first looking at just identifying the geometric sequences. And so you do like what we just did and take the second term divided by the first term. So negative 18 divided by negative 3, that's equal to positive 6. And you make sure that's consistent across your entire pattern. So take negative 108 divided by negative 18, and that is also equal to positive 6. And then check your next term, negative 648 divided by negative 108. That is also equal to 6. And your last, negative 3,888 divided by negative 648. That is also equal to 6. So, therefore, this sequence is geometric. Some of them get a little bit more difficult to identify the common ratio. For example, B, because you have fractions, and I know fractions are a little scary, but you just set it up. Take 3 over 4 divided by 1/2. Now remember when we did these complex fractions, I told you guys to write it side by side, so you could go through 3 over 4 divided by 1/2. Well, you can just multiply by the reciprocal. So 3/4 multiplied by 2 over 1, and that gives you 6 over 4, which is equal to 3/2. Okay, so let's make sure all the other fractions are the same. So take 5/6 divided by 3 over 4. Maybe on some scratch paper off to the side, just multiply by the reciprocal. So divided by 3 over 4. So that's really 5 over 6 multiplied by 4 over 3. And that's 20 over 18. And that again, that does not simplify because that would be a 10 over 9. So once you find that your common ratio is not the same, we know this is not geometric and you do not have to continue. It's some other pattern. All right. When we go to write the rules for geometric sequences, I look at these as exponential growth functions. You'll see that our rule for a geometric sequence is right here. So a sub n is your nth term, a sub 1 is your first term, your r is your common ratio, and n is your term number. So the nth term for a geometric sequence with the first term a sub 1 and common ratio is given by that formula. Let's define a few things. N is equal to your term number. A sub 1 is your first term. And R is your common ratio. So all you really need to write the rule is your first term and your common ratio. So in example 2, we're going to write the rule for the nth term. And then we're going to find the 8th term. All right, so we have ourselves our first term, that's a sub 1. Let me just write it below. So a sub 1 is the 5, a sub 2 is 15, a sub 3 is 45, a sub 4 is 135, and we need to calculate a rule. Well, we'll find our rule and then we'll use it to calculate our 8th term. So our rule, we've got a sub n is equal to our first term multiplied by our common ratio raised to the n minus 1. So we have our first term, that's our 5. We can drop that in. Now our r value we get from taking our first term or our second term. Let me highlight. I ran out of a little bit of room. So take your second term and divide it by your first term. So r, I'll write it over here, is equal to 15 divided by 5, which is 3. So we'll drop that in. And then 3 raised to the n minus 1. All right, here is our rule. And now we can use it to find our 8th term. So our a sub 8 is equal to 5 times 3. Now our n for the 8th term is our 8. So we plug in 8 for n and subtract 1. So a sub 8 is equal to 5 times 3 to the 7th power. Now make sure you follow order of operations here. You need to do the 3 to the 7th first before you multiply by 5. And you should get 10,935 is our 8th term. So it grows really, really, really fast. As we move on, we've got problem B. We need to write the rule and then find our 8th term. So let's first, we've got our first term is 88, our second term is negative 44, our third term is 22, our fourth term is negative 11. So we're going to look for our 8th term. Let's calculate our r value. So take negative 44 divided by 88, and that'll give us negative 1/2. So our rule, a sub n is equal to our first term of 88 multiplied by your r value, negative 1/2, raised to the n minus 1. All right, here's our rule. And let's use it to calculate our a sub 8, which is our 8th term. So plug in 88 multiplied by negative 1/2 to the 8th term minus 1. Simplify that down, you get your 8th term, negative 1/2 to the 7th, and that should give you negative 0.69. In example 3, this is where it gets a little trickier because they'll give you some random term number, like a sub 4 is equal to 12, and the common ratio, and we're going to have to backtrail to get our first term. So one term of a geometric sequence is a sub 4 is equal to 12. So here's a sub 1, a sub 2. I'll just make a little chart, fill in kind of what I know. So a sub 4 is equal to 12. I know my r is 2. We're going to write the rule for the nth term, which is like a sub n all the way over here, dot, dot, dot. Then graph the first 6 terms of the sequence. So we're going to fill in a sub 5, a sub 6, and kind of dot, 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 all the way down to a sub n. All right. What we can do is kind of the easiest way to go about this is maybe get your a sub 5 and a sub 6, because all you have to do is multiply by the common ratio of 2. So 12 times 2 gives you 24. And then take 24, multiply by 2, and you get your 48. Well, to go to the right, you would be multiplying. To go to the left, you're going to take that 12 and divide by 2. So you get 6, and then take the 6 divided by 2, and you get 3. And take your 3, divide by 2. Don't worry about it. It's a fraction. It's fine. 3 over 2. So there's your first term. We can write our rule because we have our r already. So a sub n is equal to a sub 1, 3 over 2, multiplied by your common ratio of 2, raised to the n minus 1 power. All right, and we have our first 6 terms. Here's our a sub n, and that's about it for that problem. Now, just like in arithmetic sequences, we could find arithmetic series by taking all the terms and adding them. So that's the sum of a finite arithmetic series. Now we can do the same thing with our geometric series. So when you take an expression formed by adding the terms of a geometric sequence, it's called a geometric series. Pretty much you're taking all your terms and you're adding them all together now. So this is a little derivation of this formula for the sum of a finite geometric series. So finite meaning it ends. Your geometric series has to end. Meaning you're not going to have the dot, dot, dot. So you've got like 2 plus 4 plus 8 plus 16. Okay, the sum of those 4 terms, you could figure that out. And this is a rule where if you have a lot of terms, it'll make your life easier. Instead of listing all the terms out and adding them all together, you can just use this formula for the sum of the first n terms. Okay, is equal to your first term. And then, of course, our r is our common ratio. And this n is, of course, our nth term, or our term number. All right, so in example 5, I'll show you the long way to do it, and then I'll show you how to use the sum formula. We've got find the sum from our first term. So from our first term to our 10th term is our upper boundary of this rule, 4 times 3 to the k minus 1. So to find our first term, we're going to plug in k is equal to 1. And that's what we're going to call our term a sub 1. So 4 times 3 to the 1 minus 1, and that will equal 4 times 3 to the 0, which is just 4 times 1, which is 4. So we have our first term. To get our second term, you're going to plug in a k value of 2 into the rule. So 4 times 3 to the 2 minus 1 will just be 4 times 3 to the first power, which is 12. To get our third term, we're going to plug in 3, and you'll see that 4 times 3 to the 3 minus 1 will be 4 times 3 to the second power, and that'll equal 36. So keep on plugging in. When k is equal to 4, you're going to get your fourth term of 108. I'm going to save some time here. Plug in k equals 5 to get your fifth term of 324. Plug in k equals 6 to get your sixth term of 972. Your seventh term would be 2,916. Your eighth term would be 8,748. Your ninth term would be 26,244. And this is kind of obnoxious. This would be 78,732. And you don't want to be doing this a lot. Like, this is like way too much work, right? Because at this point, to find the sum, just as a quick reference, remember that the summation notation really stands for, it's called sigma notation or summation notation. Oops. Sum notation. And it really means the sum of. So the directions, do they really need to say find the sum? No, not really. Okay, so now you're going to take all your 10 terms and add them all up together, and that's your answer. Okay, let me show you how to use the equation. All you need to find is your first term, a sub 1, and your r, your common ratio of r, and you need the sum up until the 10th term. So we're going to use n as 10. So the sum up until the 10th term is equal to 4, which is our first term. Plug in 1 minus r. Our r value was actually from the beginning. You can see it's 3, or you can check your pattern. 4 times 3 gives you the 12, and 12 times 3 gives you 36. Raised to the n, which is 10, all divided by 1 minus your r value of 3. Simplify that down a little bit before you enter into your calculator so you don't make a mistake. So 1 minus 3 to the 10th divided by a -2, and hit enter, and you'll see that all those 10 terms added up together will equal, 118,096. So I look at this problem, and this is pretty similar to like what's happening in the world right now with coronavirus, right? You want to see on day 1, maybe you would have 4 patients, and then on day 2, all of a sudden you have 12 patients, and then on day 3 you have 36 patients, and all the way up until the 10th day, now you have a whole lot of patients. And if you wanted the total number of patients that you've had in 10 days, this is the exact math that you would be doing for this situation. All right, so you would have technically 118,096 total patients already in 10 days. Let's practice a little bit more on our summation notation. Here's another example. Find the sum from the first term up until the 6th term of this rule. So this problem has a little trick, right? You actually have to find your first term I want you to make sure that when you find your first term, you're going to plug into the rule. The rule is right here. Okay, when k equals 1. So a sub 1, which is our first term, is equal to 1/2 times 5 to the k value of 1. Simplify that down, and that's your first term. Now, to find the sum up until the sixth term, we're going to use our rule for the sum for s sub 6. And that would equal, our rule would be a sub 1 times 1 minus your r to the n over 1 minus r. That's exactly what we used in the last problem. And then you're going to plug in your first term. You're going to plug in your r value, which is 5 in 2 places, and then your n value of 6, and simplify it down. Make sure you simplify this denominator before you enter it into your calculator, and you'll get a sum from the first term to the sixth term of 9,765. All right, and that completes this lesson. I hope this finds you all well, and I miss you guys and hope to see you guys soon.